For problem number 3, we initially noticed that we have a negative exponent, and so when that first video I talk about this. Any number can be written as that number over 1. The negative exponent is upstairs, so we're going to immediately move that exponent downstairs and make it positive. It's kind of like, well, I'll talk about that later. Ask me in class about negative and positive upstairs, downstairs. So we have 25 to the 3 halves. Well, just because that's in the denominator doesn't mean we do anything any different. We're going to take the 25 and we're going to leave that under the radical. We're going to write this expression here that's in exponential form. We're going to write it in radical form. And we know that 2 is the root. So we either have the square root of 25 cubed, or we can write that as the square root of, and we don't have to write that 2 there. I'm just writing that just for emphasis. Or we can write that as square root of 25 first and then cube that. So just like in the last example, we don't want to cube a big number. So we want to keep the numbers small. We're going to simplify this first by taking the square root of 25. Well, we know what that is. We know that the square root of 25 is 5. And now we're just going to go ahead and raise 5 to the 3rd power. And when we raise 5 to the 3rd power, 5 times 5 is 25. 25 times 5 is 125. And we have our simplified version of that original expression of 25 to the negative 3 halves, which can be written as 1 over, and should be written as 1 over 125. All right, let's find our next example. So for example number 4, we see we do have a negative number. So let's not lose sight of the fact that we have a negative number, unlike a negative exponent. So having a negative out front is not the same as having a negative in the exponent. So we're going to take the 9, we're going to make this either, again, the square root of 9 cubed, or we're going to make that the opposite of the square root of 9 first, and then cube that. Here, 9 cubed, I don't want to have to do that, so I'm going to keep my number small, and I'm going to keep that minus sign out there. We know that the square root of 9 is 3, because 3 squared is 9. And then we have to make sure we cube the 3, and we know that 3 cubed is 27. So that's it. Keeping the minus signs that are in front different and separate from the minus signs that are in the exponent position. So in this particular problem, we use that property of exponents that says that a to the n raised to the m power, that's the same as a to the n times m. So this is the property of real numbers, property of exponents, that you need to use here, because notice we have a number raised to a power, and then we have that raised to a power, so a power to a power. So we multiply. And let's think about that. 4 times, let's put that off to the side here, 4 times negative 1 over 12. And when I see a whole number multiplied by a fraction, I want to make sure I write it as a fraction times a fraction. That makes it easier for me to remember. And then I remember that I could multiply straight across. 4 times negative 1 is negative 4. 1 times 12 is 12. But I also can simplify the process a little bit here. When I'm multiplying, I can cancel like factors. You could have written 12 as 3 times 4, and when we have multiplication, we get to just go ahead and cancel the 4's, because 4 divided by 4 is 1. So we end up getting negative 1/3. So basically, all of this stuff is so that you know that when we rewrite this expression, we're going to write that as 27 to the 4 times negative 1/12, which is what we just did here, and that's to the negative 1/3. So 4 times negative 1/12 is negative 1/3. Now we have a negative exponent, and we want to make sure we write that with a positive exponent. We write it as a fraction first, and then we rewrite the fraction. Since 27 is upstairs with a negative exponent, we want to write it downstairs with a positive exponent. 27 to the 1/3 is downstairs in the denominator. So don't lose sight of the fact that we have now the numerator becomes 1. The denominator is 27 to the 1/3, which we have the root being 3, cube root of 27, and we know the cube root of 27 to be 3. So this entire expression can be rewritten as 1/3. That's kind of a neat thing here where you took this, what was a complicated looking expression, and you wrote it as just 1/3.